Alright, so here we go. Integrals of e to the x. You ready? Very simple. Okay, just like I said earlier.
The Cowboys are good though.
The only thing is that there is a little bit more depth to it. If you look in the back of your calculus books, you'll find the answers for the integrals and derivatives that we just said out loud, but there's a little bit more to it. Okay? So, for example here, do you recall when we found the derivative of e to the x, what the derivative was? It was really e to the x, right? Times what? Times the derivative of x, which is 1, and then also times ln of the base, which in this case was e. So, ln of e we know is what? 1 times 1 is 1 times that. So generally we would just say that the derivative of e to the x was what? E to the x, right? But there was a little bit more behind the scenes that was actually happening there. Okay, so if we make it more general and we say e to the u, what would the derivative of e to the u be? E to the u times u prime times ln of e. Which ultimately ended up just being e to the u times what? U prime, because that ln of e was just a 1. Right? Now this only occurs when the base is e, because ln of e is 1, right?
Yeah.
If the base was not e, then we would have a different situation. I would have to put what belonged there, right? So if the base was like 5, then it would be 5 to whatever power times the derivative of that power times ln of what? Of that 5, right? Okay? Cool? We'll talk about those tomorrow. Alright. So now let's look at these. The integral of e to the x. Okay? So, like we said, the integral of e to the x is just e to the x plus c. Okay? For simplicity. Right? But what's really happening, okay, is this. They're saying e to the x, instead of multiplied by the other stuff, now it's going to be divided by that stuff. Okay, because we're doing the integral, not the derivative. So this will be divided by the derivative of x, which is 1 times ln of e plus c. Which still ends up being what we got on the left side. You understand? But that's really what's happening. We're doing the inverse. Right? So instead of multiplying, we are dividing. So if we generalize it like it is on the bottom, okay, and this is where it got a little confusing, because kids wanted to do this right away, but they were doing u sub at the same time, so then they were getting confused. Okay, so you gotta kind of approach it differently. I'm gonna write this part for this, but just remember that it's equal to just what? The integral of e to the u is just what? E to the u plus c. Okay? What's really happening is this. If you were to treat it by itself without doing u substitution, just looking at it by itself, and you wanted to work out the problem, this is what it would be. E to the u divided by u prime times ln of e. Plus c. But you would have to look at that part in the problem by itself. Not do u, not do du, not do any of that. You just focus on that part, rewrite that part, and then work out the problem, and it'll end up working out. Okay? So for us, just remember, the integral of e to the u, once you get it to look like this, is just going to be e to the u. So we okay? But that's what's really happening. Got it? And I can do an example for some of you if you want to see that. But let's just kind of go through the process and just remember this. So if we look at this guy, and we go through the process of u sub, what would we pick for u to be? 3x plus 1. Okay, what would du be? 3 dx. So this guy right here is being replaced with u. We got the dx, got to get rid of that 3. So that's going to give me what?
3 du.
Nope.
Nope.
1/3 du equals dx. Good try. So now we're ready to rewrite the problem.
That's gonna be on the video.
Okay. zero, right? We're human, we make mistakes. So we get 1/3 the integral of e to the what? U du. So what's the integral of e to the u? E to the u, right?
Your haters be
So
recorded.
we get 1/3 e, just kidding, to the u plus e. Just kidding, I made all this stuff up. It's really 1/3 e to the 3x plus 1 plus. So if we were to treat it as normal, just by looking at this problem and not doing this, right? Does the rule work?
Yeah.
Okay.
Yeah.
This is like u, right? So we would get e to that on the top, divided by that stuff's derivative, which is what? 3. We're dividing by 3 here, right? Times ln of e, which is the 1, so it's not really there. It ends up working out. Okay. You're gonna get confused if you go through this approach and then you still want to do this. Okay. If you go through this, you're doing this, but you don't know that you're doing it. Does it make sense a little bit? Yeah. For example, look at number 2. What would we pick the u to be? Cotangent of x, right? We want this guy to be a u. What's its derivative? Negative cosecant squared x dx. Remember, anything that starts with a c, when I get its derivative, it should have a negative, right? Right. So we got almost everything. This guy's gonna go away, this guy's gonna go away, this guy's gonna be a u. Problem is that negative, right?
Yeah.
Negative du is equal to cosecant, squared x. So we can rewrite this, the integral of the negative e to the u du. Much easier, right? What's the integral of e to the u? E to the u, right? So we get negative e to the u plus c, and negative e to the cotangent x plus c. Cool? Too easy? If you wanted to approach it this way, you would have to kind of ignore this part right here and just integrate this part by itself. And when you do that, you're going to have it divided by that cosecant squared, and it's going to cancel this cosecant squared out by itself. Okay? And it's also going to be technically divided by the dx, so it's going to cancel this dx out at the same time. You understand? Sort of?
Yeah.
Yeah? Is it okay? Just go through the steps? That's easier? Alright. Let's look at these last 2 examples here. What would we pick u to be on this one? X. Okay, so then that would just give me e to the u divided by 2 plus e to the u. Does that help me fix anything?
No.
No, okay, that just gives me the problem but with different letters. And I forgot a dx here, so add it in there, I'm sorry. Pick something else to be u.
2 plus e to the x.
How about 2 plus e to the x, right?
Did you hear me? Yeah.
Let's make all that be u. What is its derivative?
E to the x.
E to the x dx. Okay, so this guy's being replaced with u. Do I have an e to the x and a dx in there somewhere?
Yeah.
Awesome, so that goes away. So we get the integral of 1 over u du, right? Oh my god,
ln of u.
what is that? ln of the absolute value of u, right? Plus c. That's ln of the absolute value of, what was u?
2 plus e.
2 plus e to the x.
Whoa.
Sir, but we're not doing those problems. We did those yesterday. Okay, they're gonna be there.
Alright.
How about number 4? What do we want u to be? Huh? Cosine of e to the x, that whole thing? Or just e to the x? Just this part right here? Okay, let's see if that works. So what would du be? E to the x dx? So this guy's being replaced with a u. Do I have an e to the x and a dx in there? Perfect. So that's gonna give me the integral of just cosine of u du, right? So what's the integral of cosine? Negative sign? Positive sign. Positive sign of u. So this ends up being sine of e to the x. Careful, okay? We're working with derivatives and integrals at the same time and it starts getting confusing. There's a lot of things to remember, right? So you gotta be careful. You don't wanna mess that up. They're gonna give you something with sine and cosine guaranteed because they know that those are the ones that are gonna get you. Good?
Wait, I just
Got it?
No, I just got here.
No, you just got here? Oh man, you get in a little bit.
Alright.
Watch the video. Like you were never gone. Next year I'm not gonna teach, I'm just gonna press play and the video. I'll be legit, right? Sit here and that way I can just grade papers, right, while the lesson's being. Alright, so let's think of this one. What is the derivative of e to the negative x? Because that's another common problem that they put on the AP test. E to the negative x times what? Negative 1 times ln of e, which ultimately is just negative e to the negative x. Yes? Okay. What do you think the integral of e to the negative x is? Negative e to the negative x, right? Right? Plus what? Plus c, right? So you can ask yourself again, it was kind of like that question that we asked ourselves, you know, whose derivative is sine, right? Whose derivative would be sine? Negative cosine, right? So when I integrate sine, I have to have negative cosine. It's the same idea here. Whose derivative would be e to the negative x, right? Well, I know that the derivative of e to the negative x is negative e to the negative x. So I would have to negate that to make it become what? To make it become positive like it is here, right? So whose derivative is e to the negative x? Negative e to the negative x, right? That's why I'm writing that out. You understand? Cool? Now if we had it generalized, e to the negative u du, what would really be happening is this. E to the negative u divided by negative u prime times ln of e. Okay? Which is the same thing that we were talking about earlier. For simplicity, if you want to remember negative, if you have e to the negative u, it's going to be negative e to the negative u. Good? Maybe we could add that one down here. The integral of e to the negative u du, negative e to the negative u. Cool? So let's try this example down here. Okay, it looks really complicated because it's a fraction. How can I make it easier? What can we take out? The 1 over 6? So if I take out a 1 over 6, now I just have e to the x plus e to the negative x dx. And should we be able to integrate those two really quickly without having to do u sub here?
Yeah.
Yes, because I should know the integrals of both of those. And I should be very familiar with them because they're going to be on the AP test. So what's the integral of e to the x? E to the x. What's the integral of e to the negative x?
Negative x.
Negative e to the
Negative.
negative x
Plus
plus c. And it's going to be all of this times what? 1 over 6. If I wanted to, it's like 1 over 6 e to the x minus 1 over 6 e to the negative x plus c. Cool? Too easy?
Yeah.
You think you won't forget that? No? That's it. If you know the derivatives, you know the integrals, technically, right? Only when you're working with these. Got it? Any questions? give you your assignment. Make sure that you work on any assignments that you need to turn in that you have 0 scored. Get those in.
Like I saw and stuff, like that. They were just like side by side.
Are you doing Spanish?
I was like, okay.
I think just Spanish. I don't know.
There's none there. They should be on this side.
Yeah.
Take one of these over there so that way it'll be one of them.
Can we show you time?
Yes, shut up. I say shut up. Yes, you should. Shut up.
You know what?
It's on June 10th.
Don't go.
How about you don't go?
I know it. I'll tell you. I know it's nothing. You say it's nothing. Believe me.
Yeah, so
It's not like anybody's gonna attack you. But...
Yeah, no.